My name is Mr. Ishengoma, and I'm going to be your host today. Today we are going to look at circle theorems. However, because the theories are many, today we are going to start with a few of them, and in the next coming lesson, we shall continue with the other theories. Now, to begin with, we cannot go straight to the laws. We need to remind ourselves a bit of the rules that are governing circles and the meaning of circles. So, first of all, when you hear the word theorem, theorem takes us back to the meaning of property. So before we looked at property. So properties and theories, they act in the same behavior mathematically. They act in the same behavior mathematically. So whenever you see a theory in mathematics, or whenever you see a property in mathematics, this means this item can never be manipulated, can never be changed. Instead, you must use it in the way it is given. You must use it in the way it is given, but you cannot change it and do something different. So whenever you change it, it means you will always be wrong. Remember, we looked at angles which add up to 90 degrees. But if you say that they are adding to 80, it means you will not be correct anymore. Why? Because you have changed the property, and the properties cannot be changed. They have to be used the way they are given to you. Okay, now let's look at the circles. Now, before we go to the rules, we have what we call lines. Inside circles, we have lines. Inside circles, we have lines. So for lines, we have important lines. These lines are very important, and we must understand what they mean in order for us to be able to go forward. First and foremost, we have the first here, let me call it number 1. The second one, I call it number 2. The third one, I will call it number 3. And the fourth one, I will call it number 4. When you look at number 1, we have got a straight line from the circumference till the center of the circle. The straight line from the circumference till the center of the circle. This straight line is known as a radius. So we have to remember all the time, a straight line from the circumference till the center of the circle is always known as a radius. Number 2, we have another straight line. Number 2, we have another straight line from the circumference to the circumference, but it is passing through the center. A straight line from the circumference to the circumference, and it is passing through the center. So whenever you have a straight line from the circumference and it goes on till the other end of the circumference, it will always be known as a diameter. Number 3, when you have a straight line from the circumference and it goes till the end of the circumference, but it is not passing the center. It is not passing the center because if you check, the center is somewhere here up. So if you have a straight line from the end of the circumference to the end of the circumference, and not through the center, this line is always known as a chord. This line is going to be very important for us students, so we're supposed to remember it all the time. As we have just said, the difference between a diameter and a chord is that diameter passes the center. The diameter passes the center, but the chord does not pass the center. So we are supposed to remember all the time. Diameter is a straight line. At the same time, the chord is a straight line, but the diameter passes through the center. The chord does not pass through the center. So we need to remember all the time. Okay, let's go to number 4. The line number 4 is just touching here, is touching the circle there where I have marked with the red. That's where the line is touching. So it is a straight line. It is a straight line just touching the curve at one position. A tangent is a straight line just touching the curve at only one position. A tangent does never pass inside. A tangent does never pass inside. When you have a circle like this one, and I want to draw a tangent, I have to draw a straight line like that. But this second one is not a tangent. So if you look, I have 2 lines. The first line there, I have ticked, will be a tangent. And the second line here, which I am marking wrong, will not be a tangent because it is passing inside. Because it is passing inside. And a tangent must never pass inside. A tangent must be touching a circle at only one position there. So whenever we have a straight line just touching a curve at one position, that straight line is known as a tangent. So students, we have seen 4 important lines. Line number 1, which we are never supposed to forget, is a radius. Line number 2, which we are never supposed to forget, is a diameter. Line number 3, we should remember at all time, is a chord. And line number 4, we're supposed to remember all time, is a tangent. These are very important lines whenever we are looking at theories of circles. Now, let's look at the basic law. Let's look at the basic law. Let's look at the basic law. The basic law here, if you look properly, let me give it a number. If you look properly, at number 1, you will see a triangle inside a circle. At number 1, you'll see a triangle inside a circle. At number 2, you will see a radius, which is vertical, and you will see a chord, a line called a chord, which is horizontal. And at number 3, you will see the combination of the 2. Number 1 and number 2, they are all combined together. Now let's go back to number 1. Number one, if you look properly, you see a triangle. Now, this triangle on number 1, you can understand it that here it is touching the center. This corner there, it is touching the circumference. And this corner here also is touching the circumference. Now, basically, we will notice 2 things. Number 1, this line is always known as a radius here, radius R. And this line also is known as a radius R. So whenever you have radius and another radius, it means those lines will always be the same, because the radius is always the same, it can never change size. So this basically tells us that this line and that line will always be equal, will always be equal. But remember, these two equal lines, they are forming triangle with this chord, So if we have a triangle, this triangle will always have these two corners equal. This corner and this corner will always be equal. So the law tells us that whenever we have such kind of triangle, this corner there and this corner here will always be equal. Let's go to number 2. The basic law number 2 says, whenever a radius, whenever the radius is this vertical line, this line from up till down. Whenever a radius meets a chord, whenever the radius meets the chord and they form 90 degrees, the box I've just drawn always represents 90 degrees. And they form 90 degrees. Whenever a radius, this one is our radius, whenever a radius and a chord, this is our chord, whenever a radius and a chord meet to form 90 degrees, this chord will equally be bisected. So whenever a radius and a chord meet at 90 degrees, it means the chord will be cut properly into 2 equal parts. Remember, it must be 90 degrees meeting for them to be cutting the chord into 2 equal parts. Now, let's go to number 3. Number 3, as I said, is a combination of the two, number 1 and number 2. So properly you can see a triangle, and properly you can see the radius, which is bisecting the chord. So without forgetting, we said, if that radius cuts the chord at 90 degrees, we said it will mean that this chord has been cut into 2 equal parts. And if it is cut into 2 equal parts, it means this part here and that part there, they will be bisected equally. Okay, now before we said number 1, if you have a radius and another radius, it means they form this angle to be equal. Remember, at all time, radius and radius, they will always be equal. Radius and radius, they will always be equal. Now, look at number 1. Again, look at number 1. When you look at number 1, at the center there is an angle which I am marking brown. At the center there is an angle which I'm marking brown. Now, this angle which I'm marking brown, if you bring it to number 3 there, if you bring this angle to number 3 here, the law says that this angle here will also be bisected into 2 equal parts. The angle will also be bisected into 2 equal parts. So when we combine number 1 and number 2, we basically see so many bisections. We basically see so many bisections. So we are supposed to remember all these bisections again. So number 1, we can see that kind of angle which we formed. And even from number 2, we can see that kind of bisection. And also the angle here, we can see how it is also bisected. So we have seen three important things. Number one, we have looked at the equal angles due to the fact that the triangle has been formed by two radiuses. That is number one here. I can put big number one with a circle. Number two, we have seen two parts of a chord. Number two here, we have seen two parts of a chord which are equal because of a radius cutting the chord at 90 degrees. And up here, we see number three there. This number three tells us that the big angle has now been cut into two equal parts. The big angle has now been cut into two equal parts. Now, I'm going to do for you these three questions when I am following the rules which we have just discussed. I'm going to do these three questions for you when I am following the rules which we have just discussed. Question number one, this is my center here. So if this is my center, this is my radius and this is my radius. Therefore, this line and this line will always be equal. So if the two lines are equal, if this corner is 50, it means even this corner will be 50. So if I have those two corners as 50, it means now I have angle sum of a triangle as 180. So it will be 50 plus 50 plus x is equal to 180 degrees. Therefore, 50 plus 50 is equal to 100 and is equal to 180. So x will be equal to 180 minus 100. And finally, the value of x will be 80. We have used the law. Now let's go to question number two. Again, question number two, it means this line here, because it's a radius, it is equal to that line because it is also radius. So if this corner here, it is x, it means even this other corner there, it will be x. Therefore, x plus 100 is equal to 180 because it is a triangle and angle sum of a triangle is 180. Then x plus x, I'll get 2x. So 2x is equal to 180 minus 100 is equal to 80. Then I divide by 2, I get the value of x as 40 degrees. On the same place here, I have another radius which will be equal. So if this corner here is 50, that means even the other corner there will be 50. Again, I will repeat, y plus 50 is equal to 180. So y will be 180 minus 50 plus 50 is 100. So this y here will be 80 degrees. Okay, then we got question number three. Question number three is basically half combination of the rule of number three. Let me show you rule number three there. If you look, rule number 2 and 3, they are combined. So when you look at those two combined rules, they're taking us to answer question number 3. So first of all, I can get the answer for W. The answer for W is easy. W will be 90 because it's the corner 90 there, based on the rule. So W, I already get the answer, is 90 degrees. Now I need to find the value of X. So basically X, even this part here will be X. Why? Because if W is 90, means this part here and this part there will be equal. So that's why W is 90. So if they are equal, means this part will be X. Then secondly, if this is 4 and this is 1, it means the radius is 5, so this part here will be 5. So if that part is 5, that means I have here, I have a triangle. This part is 4 and that part is 5. Then I can find x using Pythagoras theorem. And finally, my x will be 3. That's how we apply the basic law. Now let's go to the first theorem. The first theorem says angles subtended by an arc, angles subtended by an arc in the same segment are equal. Angles subtended by an arc in the same segment, they are equal. Now, when we talk about arc, look at number 1. Number 1, which I've just written, is representing for us an arc. An arc is a portion of circumference. So if it was circumference, it would have gone like that. So an arc is a portion of circumference. A segment is a portion of a circle formed by a chord. And if you look properly, number 2 here, number 2 is showing us a chord. And if this is a chord, means this is our major segment. And down here is our minor segment. So a segment is like this. We have major segment here in number 2, and we have minor segment. Now let's go back to the theory. Angles subtended by an arc in the same segment are equal. Angles subtended by an arc in the same segment, they are equal. Now, we go to number 3 to explain the law. If you have got 2 points A and B, if you have got 2 points A and B, these 2 points can form angles at the circumference. Watch this arrow. That arrow is one angle which has been formed by A and B using those straight lines. Again, if the same 2 points A and B form another angle there at the circumference, the law says all the angles formed at the circumference by the same 2 points, they will be equal. That law means all the angles formed at the circumference by the same points, they will be equal. There you are. So all these 3 angles will be equal because they are formed by point A and B. Now, back to the law. The law said angles subtended by an arc. Here, if you check properly, A and B is our arc. Here, A and B is our arc. And the law says angles subtended by an arc in the same segment. If you look A and B there, all the angles, they are this side. Look at the arrow. All the angles, they are that side. And that side is all the same segment. That side is all the same segment. So all those sides, they are equal angles because they are in the same segment. Now let's look at the questions here using the law. If you look at number 1, the angle X is formed by this corner and that corner. Angle X is formed by this corner and that corner. So these 2 corners which are forming X, they are also forming 20. These 2 corners which are forming X at this circumference, they are also forming 20 at circumference there. Basically, the law says these 2 will be equal, therefore our X will be 20. Let's go to number 2. X here, this X there, is formed by this line, this corner, and this corner. So these 2 points and this one, they are forming X. But again, these same points are forming 30 at circumference here. Therefore, they must be equal because the 2 are formed by the same point at circumference. Therefore, X will be 30. Let's look at Y. This Y here, Y is formed by 2 points here. Let me use another color. Y is formed, this Y here. Y is formed by this circle point and this point. But again, these 2 points which are forming Y, they are also forming 20. Therefore, Y and 20 will be equal. Let's go to question 3. We want to find X here. This X there is formed by this point and that point. Now, the same points which are forming X, they are also forming this angle here. So, if the 2 points are forming the same angles at the circumference, so it means even this one will be X because they have to be equal. Therefore, X plus 40 plus 70, I should get 180. This means X is equal to 180 minus 40 plus 70 is 110. So X will be equal to 70 degrees. Now let's look at the second law. Let's look at the second law. The second law says angles subtended at the center of the circle is twice angle subtended at the circumference. Angle subtended at the center of the circle is twice angle subtended at the circumference. This means the angle which is formed at the center of the circle will always be 2 times bigger than the angle which is at the circumference. The angle which is formed at the center of the circle will always be 2 times bigger than the angle at the circumference. Therefore, look at number 1. If I make number 1 to be 100 degrees, because this 100 degrees is at the center, it means here at the circumference, it will always be 50. Why? Because the angle at the center must be 2 times bigger than the angle at the circumference. So look at number 2. If I make the angle at the circumference here, the angle at the circumference 30, the law says the angle at the center there should be 2 times bigger. So the angle at the center should be 60. Look at number 3. Number 3 says, if I make the angle at the center to be 80, if I make the angle at the center to be 80, it means the angle at the circumference will be half. So the angle at the circumference will be only 40. So the law says the angle subtended at the center of the circle is twice the angle subtended at the circumference. Now let's look at a few questions, and I will leave you to complete the other questions. So when you look at number 1 here, number 1, number 2, number 3, number 4, number 5, and number 6. When you look at number 1, the angle at the center is 70. It means the angle here at circumference will be 35. When you look at number 2, the angle at circumference is 30. The law says the angle at the center will be 60. Number 3, if you look at the angle at the center is 120, it means the angle at circumference will be 60. Therefore, 2x will be 60. Divide by 2, x is equal to 30. Now, today we have looked at the 2 laws and the basic law. Next time we shall complete the other laws and we shall see. Now, I will send you questions to complete. Thank you for being good students. When we meet again, we shall continue with the 3rd law and other laws. So basic law has been understood today. 1st law and 2nd law we have understood.